Alright, so please pardon the low production value on this video, but I wanted to get this out since this is something that, to my knowledge, only one other person in the world has done before. So first I'm going to do a high-level overview of how ZephyrCab works, and then we'll jump into the nitty-gritty and try it out. At the heart of ZephyrCab is the simulation engine, a sophisticated program that uses information from a datasheet, such as weight and horsepower, to mimic the behavior of a specific locomotive. The user controls the whole operation from their virtual cab, a mock-up of a real locomotive control stand which works great on laptops, desktops, and even tablets. The input from the user is fed into the simulation engine, where it's combined with your locomotive's datasheet to accurately reproduce the handling of a real train. This offers unmatched realism compared to the crude approximations of braking and acceleration that are found on most DCC decoders today. The simulation engine then uses a Wi-Fi connection to JMRI to relay speed, lighting, and sound commands to your model locomotive. This means ZephyrCab supports nearly all DCC systems and all DCC decoders. If it works with JMRI, it works with ZephyrCab. So right here we have just a simple demo train. It's a Bachmann FT and 3 boxcars. The FT has a lock sound decoder in it, so even though it's a Bachmann, it's not got the cheesy little Bachmann decoder in it. This layout is powered by a Digitrax DCC system, but that's actually totally irrelevant because everything that we're doing today only requires JMRI to work. So any DCC system that will work with JMRI will work with ZephyrCab. So let's get started. So for those of you who aren't familiar, JMRI is a program that you can run on any computer that will let you interface your computer to your DCC system. So the cool thing about JMRI is that it's free software, and so since it's free and open source software, they expose a lot of the power of the application for other programs to take advantage of. And so, for example, the Y-Throttle app will let me control my entire layout from an app on my phone by making my phone or my tablet talk with JMRI. So it doesn't matter if you have a Digitrax or an NCE or an MRC or ESU or whoever. It doesn't matter who your DCC system is made by. As long as it works with JMRI, it will work with ZephyrCab. So let's get started. So right here I have my Nexus Android tablet. This is a Nexus 7 from a couple years ago, something like that. Any tablet really should work with this because this is a web app. This is not specific to the Android operating system. So I'm going to open the Chrome web browser. My Android tablet is on the same Wi-Fi network as the JMRI computer. That's required, but that's pretty much the only requirement. So I'm accessing ZephyrCab from this tablet here, and I'm connected, so I'll go over to train settings. Now what this does is, in order to create an accurate simulation, ZephyrCab has to know a lot of information about the train that you're trying to simulate. So for locomotives, it really needs a pretty extensive amount of information, more than you would want to put in manually every time. So when you set it up initially, you bind certain locomotives in your JMRI roster to a certain set of attributes. So like I would go in and say, number 1379 is a EMD GP15-1, and then ZephyrCab can use that data to create a extremely accurate simulation of how one of these would handle. And so I've done that for our FT here. You can see this CBQ2, I know, creatively named. Rolling stock is a little simpler right now. I've only got one piece of rolling stock set up on my installation right now, and it's just a standard boxcar. You can add more if you'd like, but what I'm going to do is I'm going to add my locomotive. So now I've added that to my train, and I'm going to add 3 boxcars. And so now ZephyrCab knows that we are using this locomotive, and it knows all the weight and horsepower and various coefficients of friction and all that sort of thing for this locomotive. And it knows that we have 3 boxcars, and it has some generic data on the boxcars and how their brake systems work and things like that. So now that it knows that, we can scroll back up and go over to our cab, and we'll full screen it to make it easier to use. And so now it's in full screen, and it's actually very intuitive to use on a tablet. So you can see you've got your you got all your gauges at the top. You've got a speedometer and ammeter to measure the load on the locomotive's generator. You've got all your brake pipe air gauges. You've got a wheel slip indicator, all of that stuff. And down below you've got, you know, bell, headlight, engine. Sand is not implemented yet, but it's on my to-do list. That doesn't actually work quite yet, but I'm working on it. You've got the automatic brake, which to my knowledge, other than Bruce Kingsley's Ultimate Throttle project, this is the most accurate braking system for any scale model ever, because this actually replicates the effects of having more cars and having the brakes take longer to apply. It includes the effects of you have to let the brakes charge up, all kinds of things that aren't included in the crude, you know, push a DCC function button and slow the train down kind of braking like on the TCS and ESU decoders that are coming out. This is much more accurate than those. You've got an independent brake with the bail off button, and so what the bail off button will release the air from the independent brakes, from the locomotive brakes, if you apply the automatic brake. So you can apply the brakes on the cars without applying the brakes on the locomotive, which is nice. You got your reverser that you can set in neutral, forward, or reverse. Neutral actually does work. You've got your throttle, your 8-position notched throttle, and so one of the cool things about this is that if you set the reverser in neutral and you rev up the throttle, you can hear the engine rev on these lock sound decoders that support it, but the train won't actually go anywhere. And so that's kind of a neat little novelty that you don't get with traditional DCC. But anyway, I'm going to go ahead and start the engine on this thing. And so now the ZephyrCab has triggered the appropriate DCC functions on JMRI. Alright, so we're over here and we've got our train started. Now, right now, I've got the reverser in neutral. If I rev the throttle up, you can hear the engine rev, but the train's not actually going to go anywhere. Now, if you look at the speedometer, it's set at 0 miles an hour. So that would be like if you just revved your car in park. So I'll put this back down to idling. And now we're idling again. So now I'm going to put the reverser in forward. And I'm going to increase the throttle. Now if you notice, this model is moving extremely slowly. According to the speedometer, it's moving about 1 mile an hour right now. And this should be pretty close to an accurate scale speed because I used a scale speedometer to measure the scale speed in relation to DCC speed steps, and I gave that information to ZephyrCab, and so ZephyrCab can actually make this locomotive go the correct scale speed on the layout. So right now we're at notch 1 on the throttle. I'm going to increase it to notch 2. We're going about 4 miles an hour right now. So you can hear the engine revved up into notch 2. And we're increasing in speed, but still moving pretty slowly. We're moving about 7.7 miles an hour right now. Now, an important thing to note, ZephyrCab is not smart enough yet to know that we're going up a hill. And so in real life, the train would have to work harder to get up this hill. My layout does not have block detection or any of the stuff that you would need to factor that in the simulation. If somebody wants to chip in who has block detection and some of the more advanced stuff like that on their layout, I'm happy to add that as a feature. It wouldn't be very hard. I just don't have it here. So try to ignore the fact that it seems to be just climbing up the hill effortlessly, because the simulator is not aware that there's a grade. So now we're going about 15 miles an hour. I'm going to increase the throttle to notch 3. Whoops. So now we're in notch 3. And our speedometer says 16 miles an hour, and we're drawing about 140 amps. So once we come around the curve here, I'm going to start decreasing the throttle. So now we're back in notch 2. And notch 1. And idling. Now once again, try to ignore the fact that we're going up a hill. Obviously a real train would coast a lot less up a hill, but just bear with me here. So we're going 14 miles an hour and slowing down, but so we're just coasting right now. I'm going to apply the brakes. I'm going to apply the automatic brakes, the brakes for the whole train, by dragging this slider over here, and I'll make a 10-pound reduction. And so now my brakes are applying, and you can see my brake pipe pressure dropped, the control pipe pressure dropped. I'm going to go ahead and bail off the locomotive brakes, and you'll watch the brake cylinder go down to 0 psi. And you can see we've slowed down, and we just stopped. Speedometer says 0, so we've come to a stop. Now, when I want to release these brakes, those of you who know about the brake system on trains know that these take a little while to charge back up the air reservoirs in the cars because of the way they work. And so if you release the brakes and then you apply the brakes again without giving the brakes enough time to fully recharge, you'll still get some braking effort, but you won't get the full amount that you had the first time. So, and that's actually replicated in this software. So if I was to start going again and then make another 10-pound reduction without giving these brakes time to recharge, we would get less braking effort out of the train. So just as another example, one cool thing that this will do is wheel slip. So if you give the locomotive too much throttle at once, then the wheels will slip and your train will barely move at all. I'm going to put this in like notch 6 or 7 right off the bat. And you can see our wheel slip light came on, and we're only moving like less than 1 mile an hour. All right, now of course, all of this works if you put the train in reverse just as well. So I'm going to go over here to my cab now, and I'm going to put the reverser in reverse instead of forward. And I'll turn the bell on just for kicks. And we'll rev the engine up. Now you can hear the engine has revved up, and we are moving backwards. Speedometer reads 0.8, 0.9, 1 mile an hour. So we're moving backwards very, very slowly. Again, remember that the simulation is not aware we're descending a grade right now. So I'll rev it up one more so we can pick up speed a little bit, and we'll walk over here with it. Now, ZephyrCab will work with any DCC decoder. Sound support for things like the horn and especially revving up the prime mover, that is limited to certain decoders. It's not terribly difficult to add support to a decoder. But the good news is that simple DCC decoder support is available for all decoders. So regardless of make and model of your decoder, you'll have support for speed and direction and the headlight on any decoder without any additional code required. So and I'll continue to add support for more sound decoders as time passes. So I'm going to shut the bell off. And I'm going to go ahead and let off the throttle a little bit. Bring it back down to idling. So we're going to coast down this hill. We're going about 11.3 miles an hour right now. And now I'm going to apply the brakes. I'm going to make a 20-pound reduction this time, just to see what it's like. I'm going to go ahead and bail off the locomotive brakes. And you can see we're already going about 5 miles an hour. We're slowing down very quickly. And we've just come to a stop. So the braking on this is unparalleled in realism. None of the simulated brakes on DCC decoders even come close to the realism that this gives you, because DCC decoders are just using simple exponential curves for braking and acceleration, while this is actually using real physics. And so we factor in the weight of the train and the weight of the cars and friction and how hard we've applied the brakes and all this stuff to give it dramatically increased realism over everything that we've had up to this point. So I hope that you guys have enjoyed this little demo. I would love to have some of you try this software out. I'm happy to help set this up if you're interested in testing it out. So if you want to test it, just jump in the Getter chat or send me a message on YouTube or something, and I'll get in touch with you and help you set it up on your layout and help you import your locomotives and all that, so you can get going with it. So thanks for watching.